Alright, welcome to tutorial, the final tutorial for spring. So we're looking for solutions to these particular problems. Sketch the graph of the given function for one period. In each case, be careful to indicate where the graph crosses the x-axis and also its amplitude. So this is not difficult, but what I would encourage you to do in doing these is to set up your comparison. Okay, comparative techniques are used in maths widely, and I think that we probably don't emphasize their importance enough. So just like y equals x, I would put a little dashed version of sine x together and put it like that and just mark those off so that I've got a sense of comparison. So I've got somewhere to compare. It doesn't have to be completely perfect in all of its development, but it's just giving you an ability to develop your intuition. Okay, so developing your intuition. So the first thing we notice is that in this particular example, everything remains the same except that the amplitude has increased. So the amplitude is defined by this coefficient 3, and so all that's happening is that it's being brought up to 3 and down to -3 in its cycle. So that's not a big traumatic event in the life of sketching this 3x. And we can easily see how it's impacted by comparison with the other one. Okay, so very, very straightforward in terms of what's happening. The period's the same, the displacement is the same, it's just that the amplitude has been increased. Alright, so in actual fact I'm going to do 5b on top of this one as well. I'll just change colours. Okay, so b is going to be this one. Now it's 5 sine x, so it's going to come up to 5 and down to -5. So it's the same kind of thing. Okay, it's going to come up and ramp up beautifully and swoosh at 5 and swoosh all the way down, and then we just mark this out here and swoosh down you come and swoosh back up to 2 pi. So in that sense it hasn't changed either. Okay, it's clearly visible what's happening with your intercepts, etc, etc. So it's worthwhile doing a couple of these. I might put a few more on here. For C, I'll use the watermelon colour. Now it's 5 on 2. So 5 on 2, what's that? 2 2's are 4. So 5 on 2 is 2.5, if I'm not mistaken. 2 2's are 4 plus 1, 2.5. So it actually just goes a little bit less. So if that's 2, it'll be 2.5. So it's going across to this point. -2.5 is going to be down here. So -2.5 will be across to this point. So it's a little bit less. A little bit less than the 3. Okay? So up it goes, swoosh, down it comes, swoosh, down it comes, swoosh, up it comes, swoosh. Are you bothered by the unneatness? I'm not. So the thing is, what we'll continue to do is to understand the nature of these graphs by building intuition. You can get all pedantic about this and that, but at the end of the day, if you don't have a visual sense of it, the topic is going to be quite hard. Alright, the next thing we want to consider is D. Y equals -4. Wow. So there's -4. That's not what it meant. 4. It just meant that it was going to be minus, wasn't it? So it's going to go up to here, or here, we're not sure yet. We'll figure that out in a second. Or over here, or over here. So which one is which? Well, the minus sign, -4 sign, tells us that everything that sine does gets multiplied by -4. So it gets effectively upside down. So if we come and did a 1 times -4, it'll be here. So where we're going, here we're going minus in the negative direction. Then we're going up where this one's going negative. Minus minus makes up plus. So it's going up and then down, swooping down. Okay? So very straightforward to keep it visual, to keep your eye on the prize, and not deviating too much from, the anticipated idea. So, all right. So the next thing we want to consider is I'll do E on a different axis. Okay, fair enough. I've worn out my welcome. See you later. You can go away, and we'll go to E, because why have we changed? What have we changed to? We've changed to cos. So there's cos. So we just do our normal, beautiful cos waveform, plunging down, as it were, plunging down to a similar height and returning up to a similar place. Now I could have put it all like that, but that's y equals cos x. So what about 3 cos x? 3. That one's minus 1. So I need to go minus 3. So we're starting off up here, are we, and plunging down to the same location. Coming all the way down to here and plunging back up to the same location. And all the way up here. So we've basically got it built up. So let's do that in orange. Let's do E as orange. So we're going to go on 3 cos. So we're going to start off up here and plunge down. Here we go. Plunging down to our cos waveform. Further we down, decreasing function all the way down to this location with the minimum. Then it starts to rise beautifully, soaring up. See the change of language? Soaring up. Beautiful. A rising function. Okay? So, lovely sine wave. What about F? 5 cos x. You'd have to do it to me, wouldn't you? You'd have to do it to me. You'd have to make me go up to 5, wouldn't you? And all the way down to minus 5. Being a bit cheeky there, aren't I? But anything else has changed? No. Whoosh, plunging, down we go. Whoosh, all the way down we come. All the way up, we soaring like an eagle. All the way up the top. Till we get to that 2 pi place. Okay? It's the same. It's just superimposed. It's not hard. Okay? Alright, what have we got for the green one? We'll do the watermelon one. 2.5. 1, 2.5. So 2.5 will start here. 2.5. 1, 2, 2.5 will come here. So just being a little mindful of where things are. And off we go. 2.5. Cos x. Whoosh. Down we go. Whoosh. Up. Soaring. Up. Had to check myself there, didn't I? Okay. At 2.5. 5 on 2. Minus 5 on 2. Okay. And of course minus 4x. You had to do it again, didn't you? So we'll put a 4 in there. Minus 4. And a 4 in there. Now what does it mean? Minus 4 cos. So if cos started up here, cos is going to start down here and it's going to plunge. It's going to rise. It's going to soar in the same cycle. It's going to go whoosh. Bit wobbly. Whoosh and turning point. Soaring back down. Falling down all the way down to this end here. Whoosh. Okay, my penmanship's a bit wobbly. I could put that together in a cartoon, couldn't I? I think I might think about how I do all of that. Alright, so we basically covered 2 sets in question 1, so that's not too bad. Alright, question 2. What's question 2 going to bring us? Question 2 is going to question our ability to interpret amplitude. Because what we've got with y equals sine 3x. So I'll probably do these separate. So just y equals sine x. Y equals sine x. Y equals sine x. Now we know the period is equal to 2 pi over b. And so for part 2, for part A, we've got y equals sine 3x. So this is our B. Okay, so our period is 2 pi on 3, or 2/3 of pi. Now I've taught you to do that. I've taught you to separate it out and do a count. So it's effective here too. This is 2 pi, and this is pi. So all we're doing here is breaking pi up into thirds. That'd be halves, so a third is about there, isn't it? 1/3, 2/3. The period's 2/3 pi, so that means this period is being completed earlier. Whoa! Much earlier. It's going through a whole cycle. 1/3 is a half, so that's like our pi, 2 pi pi, and so it's turning around here. So the maximum's here for this one. Or actually, it's going up and down, isn't it? Going up and down, so the maximum's halfway. There it is. And halfway. There it is. So it's going to swoop up. There you go. Off you go. Sine 3x. Sine 3x and back down. Okay, and then bit out of scale, Jason. I know, but we finished early. Okay, so sine 3x, we finished early. Wow, interesting. Okay, very interesting. That's for part A. So part A was good. Part A was good. All right, so what about... now you can check all these with Wolfram, of course. You just do a plot. There's nothing wrong with doing that. Validating, but your intuition requires you to recognise so much, and so it's probably more important for you to do this. Now, who can tell me what's wrong? Question 2a was sine 3x. Nothing's wrong. Beautiful. I just had a little panic attack there. They're laughing at me already. So B is equal to y equals 3 sine 2x. So we've got a change here. So the period is still equal to 2 pi on B, which will be 2 pi on 2, which is just pi. So it's going to be finished in a period of pi. So we'll put our I know, every time, yeah, I know, but you know what? It's just easier. Until you build your intuition up to robust, resilient heights, we'll just keep doing our little 2 pi, 1, minus 1, okay? Just humour me. So our pi is our endpoint. We're finishing here. Our amplitude is 3. Ooh. 2, -3, 2, 3. All the way up there. So we're still on sine, aren't we? So for sine, we're going to be going all the way up. Oh, no, be careful. We're finishing at pi. So that means half a pi we're cycling. Okay, a quarter of pi, we're going to be up here. A quarter of this one, we're going to be down here. Okay, so up we go, shoop, shoop, and down we come. Through, shoop, and back up, and we finished our cycle. Okay, we finished our cycle. So we build an intuition. A 2 means earlier, doesn't it? Earlier. So we're finishing earlier, the other one comparatively. Now, if you didn't compare, you wouldn't know. So compare. Comparisons is a great way to do things. They do it in sequences. They do it in all kinds of mathematics. Okay, so do a comparison. Plot out your original one. Do a comparison just to check that you're in the right part. It's happening earlier and higher in that one, isn't it? All right, let's go for a Lelo. So we're going for C now. So for C, we've got y equals 2 sine 3x. No idea what this is all about. But you know what? I can do a bit of a calculation, can't I? 2 pi on 3. Oh, that's that thing. 2/3 pi again. It's got an amplitude change of 2. I'll do the comparison study. So I can do that comparison, and that'll give me a good chance. So I've only got to go for nice, swoopy sine wave. Down you come again. Down you come again. Up you come again. Oh, went a bit far this time. So there's my 2 pi. There's my pi. 1 minus 1. Wow. Okay, so we're going to put together, what are we on? We're on the yellow, goldy colour. Yeah. Alright, so this time we're going for 2 because the amplitude is 2. So it's double. And we're going to finish now at 2 pi on 3. So there's our pi. 2 pi on 3. I said it, didn't I? 2/3 of pi. How are you thinking? How are you saying things? Can you do that? Half pi, 2/3 of pi, a third of pi. Can you make that work? So we're finishing early again. It's a bigger number than 1. So we're finishing early. But this one's still lumbering along. And this one's going to go pa-chung, pa-chung. So it's going to come up to 2 in the first quadrant, down to -2 in this quadrant. And away you go. Wow. Plunging. A decreasing function. Plunging. And then increasing, soaring. Soaring up, up, up. There you go. So that's 2/3 pi. Okay, this one here would be half of 2/3, which would be pi on 3. Why is it pi on 3? Well, apart from the fact that it's a third of pi, it's a half. So 6 2/6 is 1/3. Where's this happening? A half of pi on 3, which would be pi on 6. I think we've had this discussion before. Another pi on 6, but it's a count, isn't it? Pi on 3. This time we've got pi on 6, 3 plus pi on 6. Wow. We could subtract the difference. What could we do? We've got to add another pi on 6 to pi on 3. Pi on 3 plus pi on 6. 2 pi on 6 plus pi on 6. It's 3 pi on 6. 3 pi on 6 is, look at that, pi on 2. Did you see it? Did you see that? Half a pi. Pi on 2. So it's possible to find all the locations without too much drama, just by using simple arithmetic. Now, if you want to standardise those and make them all 6s, you can make them all 6s, or you can make them all whatever you like. I'll leave you to annotate according to your question. What's the question asking? Okay? Indicate where the graph crosses the x-axis, but it doesn't actually tell us to do it in a particular frame. It doesn't say make them all the same. Okay? So that's C. Very good. 2 sin x. Alright, so we'll move on to D. D is y equals cos 3x. Okay, so we're going to do our reference waveform. And what are we doing? Cos, be careful. Cos, down you come. Nice and swooping down beautifully. Swooping down to the steepest point. And starting to catch up a bit. And rising. I even need to increase that, buddy. Rising. There you go. So there's our 2 pi cycle for cos. There's our pi cycle. There's our 1 and our -1. How good are we? But it doesn't want that, does it? No, it wants y equals cos 3x. So we need to work out the period. The period, please. Period is equal to 2 pi on 3. Oh, 2/3 pi. What's going on with this? 2/3 of pi. Pi. 1, a half a pi. It's there. That is it. Yes, I think you're right. 2/3. 2/3 pi. So we're going to be finished by the time this one's just getting started. It hasn't even gone negative yet. Okay, so we're going to be going up here. And our maximum negative is going to be here. So we're going to be plunging at these half points and rising at these half points. So you've just got to plunge, away you go. Down you come. Swoop. Up you come. Rising. Boom. So what was that? 2/3 pi. Okay. Half of 2/3 of pi is what? 2 on 6 is 1/3. 2 6, 1/3. Pi on 3. Oh, okay. Pi on 3. Well, that makes sense. 2/3 pi, pi on 3. Okay, very good. All right, where are these points here? Where are these points? What's half of pi on 3? Pi on 6. Pi on 6. So we have to add pi on 6 to get to here. Pi on 6 plus pi on 3 is going to be 2 pi plus pi is 3 pi on 6. 3 pi on 6 is pi on... Oh my goodness. Pi on 2, did you see it? There it is, pi on 2. Pi on 2. So we've managed to put all the bits and pieces together. Okay, and 0, don't forget 0. Where it all happens. Just do some simple additions. Adding fractions, who knew? Who knew it never left us? Adding fractions never left us. Alright, I want to do another one. Oh, I'm sticking, so we're going to have the watermelon one now. Great. Great colour. T, E. What's E got for us? Y is equal to 3 cos 2x. So it's an amplitude change and a period change. So we'll have cos again. Off you go. Cos swoops down, and comes back up. Okay, so there's our 1 and our minus 1. 2, 3, 2, 3. Okay, 2x period is equal to 2 pi on 2. So the period's pi. Just be careful now because the period's pi, it's here. See, this is why the comparison's useful. Okay, period's pi, so it's finishing here. That's very good. Half a pi. There's half a pi. So it's going to be coming and finishing half a cycle here. And this is where it's going to cross. Across. Okay, so we'll go back to the watermelon. Grape. And then we'll say, right. We're going to start off at 3. We're going to go to minus 3. So we're going to plunge all the way down here. Here we go. Plunging. Whoa. Fantastic. And then all the way down to minus 3. Plunging. Whoosh. Now we're on the rise. We're soaring up. Soaring up. And all the way to the top. Soaring up to the top. There you go. Very good. Okay, so we can do all of these parts again, can't we? If the period's pi. Okay, so halfway will be pi on 2. So that's this point here. Pi on 2. Minus 3. Half of pi and pi on 2. So we'll go down here and we'll do this one. Half of pi on 2 is half. 2 2's are 4. Pi on 4. Oh, very good. Pi on 4. Okay, the next one. Pi on 2 plus pi on 4. Pi on 2 plus pi on 4 is going to multiply 2 pi plus pi is 3 pi on 4. Oh, 3 lots of pi on 4. We know that one. 3 lots of pi on 4. So we've managed to find all the places where all of these values. We can put pairs together now. Okay, we can put the pairs together if we need to. Okay. Very good. That's all it is. It's quite straightforward. Okay. E. Let's do one more F and then I'll do a new video. Okay, so we're going to do F with a new colour. Let's go for F. And F is 2 cos 3x. Y is equal to 2 cos 3x. That's our point there, our period. It's going to be 2 pi on 3. Oh, back to 2/3 on pi. I wondered where it had gone. So we'll do our comparison. It's a cos waveform. Okay, it's a cos waveform, so we're going to plunge at 1. Down we go. Setting up our plunging, rising 2 pi, 0, 1 and minus 1. And we're going to 2, aren't we? 2 and minus 2. We'll go back in colour. Back in colour, please. So 2/3 of pi. So there's our pi, which we mark for comparison. And so we're going to split it up into 2/3. 2/3 of pi. So there's our place. Okay, it's going to be finished by here. It's going to be finished by here. So that means it's got a lot of work to do. So we've got to halve those and halve those. That's the same point. So we're going to plunge down. You ready? Plunging, going. Zoom. And we're going all the way down here. Zoom by symmetry. Zoom. And we're going to come all the way back up here. Soaring. And all the way back up. Soaring. Okay? That's all it is. So this point here is half pi. So pi on 2. Easy peasy. Coming down here, this was half. If that one there is 1/3 of pi, or pi on 3, because this is 2/3 of pi, that was the other third marker. So 2/3 and thirds, what we've got to do is halve 1/3 to get this point here. So half of 1/3 of pi is pi on 6. So that's pi on 6. So now we know that little bit is pi on 6. We know what this little bit should be here. Okay, so all of those things line us up. Very straightforward. So we get 0, pi on 6, pi on 3, pi on 2, 2 pi on 3. So we've done very well. Okay, so just keep adding, subtracting, do your comparisons. Try not to do it on your own. Sketch a comparison, because then you can just divide it up by sight. You don't have to worry about doing these kinds of awkward calculations. We can keep the calculations simple. Alright, that's it for me. I'll be back for the next bit. See you soon.